Hello. In this video I wanted to go over some special factoring techniques that you will use in your coursework. The first one is about factoring the difference of two squares, and the way that works is we have a squared minus b squared. We can factor something like this down to a plus b and a minus b. Now this is just kind of a pattern that you can examine to be able to factor this, and you do see this quite a bit in any of your work or any future courses or algebra. When it comes to factoring, you see these things quite a bit, this one in particular. So let's look at this quick example, and then we'll do a couple more that are a little more complicated than this. But we have x squared minus 4 here. Notice that x squared in this case is a squared. So that means that a is just x. And then notice here that this is also a perfect square, this 4. So 4 we can say is b squared, which means b would be 2, because 2 squared is 4. So I can factor this down to x plus 2 and x minus 2. And in fact, if I FOIL this back out, you will see that we get back this particular polynomial here. So let's look at those more complicated examples. The first one, we want to look at this, and I'll do them here in this empty space. The first thing you want to notice though for this one is that there is a common factor that we can factor out of this. What we should observe here is that both of these terms have a 2x that we can factor out of this, because 2 goes in both 8 and 18, and x goes into both of these, okay? So we can take this 2x out. We take the 2x out, and what we're left with, here we'll have 4x squared from this, and here we can take out the 2x and we'll have 9x. I'm sorry, we'll have 9, not 9x. Here we have two different squares that we have to deal with, a difference of two squares. This is 2x squared, okay? So just take a note here that 2x squared, if we square that, that gives us 4x squared here, okay? And this is 3 squared. So what we can say then is that we can factor this down to 2x, and we can factor this part down to 2x plus 3 and 2x minus 3. So this would be the answer to that. All right, let's take a look at this one. What do we see here? Well, we see again a difference of two squares. It's not quite obvious, but this is actually just z to the 4th is just z squared squared. So that's a squared is z to the 4th. That means a is z squared. So I can factor this down to z squared plus 4 and z squared minus 4. Okay, so we got that here. Now, but be careful, we're not done, because again we have another set here of another difference of perfect squares here. Now we look at this one though, this one we can't factor, so we leave that one alone. But this now can factor down to z plus 2 and z minus 2. So this is some examples of using the difference of two squares. Let's move on to another special factoring topic. All right, another type of pattern that you could see here in special factoring section is perfect square trinomials. Now, these ones are not always the easiest to spot. And also note that if you can do this, you could always factor it with other techniques that you learned before, like, you know, finding the two numbers that multiply to give you this, that add up to give you that. You can use those techniques to factor these. So these aren't necessarily ones that you have to know off the top all the time, off the top of your head. But it's always good to know all these different patterns that you may see, because sometimes you will want to use this because it can save you a lot of time, especially if you understand how to use it. Let's take a look at an example to see that. Alright, what we have here is we have this polynomial here. It's a trinomial, and we want to factor it. And we're going to use this perfect square trinomials setup for this that we just went over. And I want to bring that back up for just one moment. If we're looking at this real quick one more time, one thing to notice here is this sign here, okay? So the key here is that, like, if I have a squared minus 2ab plus b squared, I can factor it down to a minus b squared. And if you see if they're all pluses, it's a plus b squared. Let's go back to this example. What we see is we have a minus here. So if this example is going to work using this formula that we have, we know it's going to end up being the a minus b squared formula. But we first have to check to make sure this works. Now, before we continue, as I said before, we certainly could do factoring with the AC method, as you've seen in the previous video. But let's see how much time this saves. If we know this formula, we can recognize that we can use it here. So what I can say here is this. I can say that 4x squared, well, that's just a squared. Okay, so a squared is our 4x squared. And then if we said b squared is 25, well, the first thing that we need to make sure is able to work, are these perfect squares? Can we take the square roots of them? The answer to that is yes, because if we have a squared is equal to 4x squared, that means then that a equals 2x, okay? Because if I squared this now, I would get back 4x squared. Likewise, b here is going to equal now 5, all right? So if a is equal to 2x and b is equal to 5, let's look at this again. We need to see if this 2ab part works out here for this to make sure that it works. And I know this is taking a little bit longer than it should, but the better you get at spotting these, the faster you get at them. So we have an a squared and a b squared that we know it will work here. We know we have perfect square that we can put in for a and b. We just have to make sure now that we get 2ab in the middle. Let's look at that. What is 2ab here? Well, 2ab is going to be 2 times this, 2 times this right here, and b is here. So this is 2ab. Well, what does that give us? Well, 2 times 2 is 4, so 4x, and 4x times 5 is 20x. So as you can tell, we have 2ab here. This is minus 2ab then. Here's b squared. And this is now a squared. We can confirm that because we've just checked it all. And going back here, that means that we can use this a minus b down here as our factored form. So that means we can factor this down to a minus b all squared. So this factors to 2x minus 5 squared. And that is how we get to it. All right, there's plenty more special factoring things to talk about, so let's move on. Here's another special factoring technique when you're dealing with cubes, okay? Perfect cubes. We have the sum and differences of two different cubes. The sum and differences of two cubes, and there's these two formulas that we can use to quickly factor them down. Again, there's a pattern here to recognize. Notice when it's a cubed plus b cubed, we can factor it down into a plus b times a squared minus ab plus b squared. And a cubed minus b cubed is a minus b times a squared plus ab plus b squared. Let's look at an example to factor a sum or a difference of a perfect cube so that we can see how this formula works. Okay, here's an example. We need to factor 64x cubed minus 125. Now, these aren't always the easiest to recognize if you're not familiar with what all of the perfect cubes are, especially as the numbers get much larger. It may be difficult for you to recognize that it's a perfect cube, so you might have to use a calculator to see, can I take a cube root of all of these? And if you can, then we know that we can use this sum or difference of two cubes, because we'll have two cubes here, okay? So remember the formula. In this one, we're only going to do the difference. The sum, you'll do it the same way. You just have to use the correct formula for that one, but it's done the same exact way. Let's take a look here how we would do this. The best way I can think of is we'll first say, okay, a cubed is 64x cubed. Okay, so we'll say that. And then we'll also say that b cubed here, we're going to say that's equal to 125. All right? So a cubed is 64x cubed and b cubed is 125. Move this down here. Okay, so now what we'll say here, since that's a cubed, then that must mean that a, that's easy to find. We just cube root this, 4x, okay? So the cube root of 64 is 4. The cube root of x cubed is x. And for b, then we can say, okay, for b, that's just 5 because the cube root of 125 is 5. So we have a and b, and we need to have a squared and b squared also. Well, if you know a is 4x, then that must mean that a squared is 4x squared. So that is 4x all squared here, which we can write as 16x squared. All right? And b, that one's easier to deal with. B squared is 5 squared, which is just 25. Now, why did we find a squared, and b squared? Let's take a look here. If we notice in this formula, with the difference of cubes here, we see that we need a and b here, right there. We also need to have a squared and ab and b squared. So we need all of these in order to use this pattern. So since we have them all, let's just list them all out then. That means we can factor this down to a minus b. So a minus b, that's just 4x minus 5 times a squared. We have that, 16x squared. Then it says it's plus a times b, if you look back at the formula. So plus ab, so ab is here, and this times this, that's 20x. And then it says plus b squared. Well, b squared is 25. And there we have it. We have factored it down. So this would be, using that formula, the perfect cube, the difference of perfect cubes, we could get to this that quickly. And again, the more you practice it, the easier it gets. All right, let's take a look at some more special factoring. Sometimes you may have to factor something that is in quadratic form, but it's not quite something that we're used to seeing. However, there is a technique to use in this section that we can turn it into something that we're more used to seeing. Take a look at this example. What we have here is we have x to the fourth plus 5x squared plus 6. We're not used to seeing it like this, so what can we do here? What we'll do is we'll do a little substitution, all right? We're going to say here, let's let u equal x squared. Now, why did I do that? Well, the reason I did this is because now I can write this as, I can say then that this is simply, since x to the fourth is really the same thing as x squared squared, then what I can say is that this is equal to u plus 5u squared plus 6. If we just look at this by itself, this we know how to factor because we can take two numbers that multiply to give me 6 that add to give me 5. Those two numbers are clear to us because we've seen this before. We should be very good at this by now. This is u plus 2 and u plus 3. Okay? Again, because 2 times 3 is 6 and 2 plus 3 is 5. So what we have to do at this point then, all we have to do now that we got it here is just replace back u with what we said it was. Well, u is x squared. So we can now say that the answer to this is x squared plus 2, x squared plus 3. This would be your answer. Sometimes you'll run into this. So sometimes you need to make sure that when you're factoring, if it's some power here that you're not used to seeing, that's not a squared, for example, or a cube, now that you've seen a way to do that, there's this technique that you could possibly use. And sometimes there's all kinds of techniques that you could use. So let's talk about some strategies that we can do to try to figure out how to factor particular problems. So here's some strategies, and I've put them together in a form of questions. I wrote these down, but I wanted to put them in forms of questions here because these are things you can ask yourself while you're factoring to see if, you can do any of these. The first one we always check for, and this is we always want to check for this. Is there a greatest common factor? If there is, we want to factor that out immediately. The next thing we want to ask, is it a difference of squares or cubes? Those are easy to recognize. So you can kind of cross that question off right away once you've checked if there's a GCF. However, it may come back into play later, which we might see in an example. Next, is it a trinomial? Can we factor that? We need to check whether there's the two numbers that multiply to give the last term that when you add, you get the middle term. We need to check that. We also need to see, can we use the AC method? Can we do factoring by grouping? So we need to check all of these things. And if the answer, when we finally say no to all of them, then it's completely factored. Let's look at maybe two examples here. Okay, here's our first example for using the different strategies. Remember, the first thing we always want to look for, is there something common that we can take out of this? And the answer is yes. We can factor out a 3a from this. Okay, because 3a goes into all three of these terms. If we divide this out by 3a, we're left with 2a squared. This will give us minus 5a. And here we would have minus 12a. I'm sorry, minus 12. Now what we want to do is see, now we have a trinomial here, so we want to see if, can we factor this? Well, we know we can't use the find two numbers and multiply to get this to give me that because we have a coefficient here. The only other thing we can do is check to see if the AC method would work here. Let's do it. A times C in this case would equal 2 times negative 12, which is negative 24. And B here is equal to negative 5. Now, are there two numbers that multiply to give me negative 24 and add to give me negative 5? Well, let's think about it. I think we could probably say that 8 and 3 look like they could work. What if I made the 8 negative here and the 3 positive? Well, multiplying these two would give me negative 24, and adding them would give me negative 5. So those work. So let's now rewrite what we have. 3a. Now we have 2a squared. And instead of writing this, we're going to use our new terms that we found. Minus 8a plus 3a minus 12. So now we can do this by grouping because we see 4 terms here. Let's group this, but let's kind of put this 3a to the side for a moment. We'll bring it back. But I want to just focus on this part right here. So let's not forget that we had this here. Looking at this, we'd have 2a squared minus 8a. We could group that together. And then we would have plus 3a minus 12. Well, we see in this part here, we can factor out a 2a out of this. And that would leave me with a here, a, okay? And that would leave me with 4 here, a minus 4. Now, on this one, I can take out a 3, it looks like. I can take out this 3. And if I do so, I will have a minus 4. Now remember, we always wanted these to be the same, and they are. So we write down what we see the same. And we write down these two here. And let's make sure we don't forget that this was here all along. So this is going to be completely factored at this point. Notice we had to do a few of those steps there. We had to check. We had to say, is there a GCF? And there was. And then we had to check to see if we could factor this trinomial, and we were able to. We had to use the AC method and then by grouping. But once we get here, when we ask those same questions you just saw, the answers for all of them is no. This is all factored down. Let's look at one more. Okay, here's the last example. What we can see is that we have 4 terms here. So, first, is there a greatest common factor between all 4 terms? And we can tell that the answer to that is no. Not all 4 terms have x squared in it. Not all 4 terms have a y in it. Not all 4 terms have something of a factor of 2 in it. So all of these factors, out of all of these terms, there is no GCF. So we can cross that off for the moment. But one big hint here, when you see 4 terms, what I like to do is I always like to check factor by grouping. So let's do that. Because 4 terms, you kind of associate that by grouping here. So if we group these together, we got x squared y plus 2x squared. That's these two get grouped. We want to factor out this negative. That's always the key here. So this becomes y plus 2. Okay, let's factor out this side here. I think we can take out an x squared, it looks like. So if I take out an x squared, I'll be left with y plus 2 here. And over here, I already have the y plus 2, so I'll just take out a 1, and I'll have y plus 2. All right? Now, remember, we write down what we see the same of. And we check what else is left over here. That's x squared minus 1. And some of you may be saying, okay, good, we've got it. We factored it down. Let's make sure. This one, yes, it is factored down all the way. This one looks like a difference of 2 squares. Okay, it's a difference of 2 squares. We could say we'll write this as y plus 2, and we could factor this down to x plus 1 and x minus 1. Now we have it completely factored. Now there were a lot of different problems you saw in this video. There's so many different ways to factor something that may not all work, but there's so many different methods. You got to know which method to use at which time. It takes some practice, it really does. But just keep working at it and you'll see that you'll get better and better at it. It's very, very important that you know how to do it. It's good to get practice in and just keep working at it.